everyone. It's Mrs. Pettit. I just wanted to go over this one more time. I understand that the sound wasn't too great on the original one, so I'm going to go ahead and do this again so that everybody's ready for the test. I know that a lot of you have already heard your short answer. If you feel like you want to go back and take a look at it again and we have time in class, I will let you do that. I'm not going to even start grading short answers until next week. So those of you, especially in my 5th period class, if you want some more time, as long as you can finish your multiple choice, then I will give you some time to work on your short answer as well. Okay? So for this, I wanted to go over this with you again, showing you how to do box and whisker plots, and not box and whisker plots, linear regression and stuff. And I'm of course looking for my calculator. Hold on just a sec. So we're gonna go ahead and do a line of best fit and do linear regression. So I'm going to take you through this. I've drawn out this line of best fit already. It's basically pretty self-explanatory as we go through here, but please make sure both your axes are labeled quite well. All right. So when I do this, I'm going to go ahead and turn my calculator on. I'm just going to reset it. Okay. And I'm going to go to my mode and go down to where it says Stat Diagnostics. I want to turn it on. So I go over there and I press Enter to make sure that it's highlighted. And then I just press Second Mode, quit out of it. And then I enter in my data. So I have Stats and Edit. And under L1, I'm going to put the age and months, which is always my explanatory variable, my X value. So that's 18, 19, 25, 28, and 29. And then I do my height in inches. Okay? And again, I'm just using this data from this table right here. So 76.5, 77, 78.1, 78.2, 78.8, 79.9, 79.9, 81.1, 81.2, 82.8, and 83. Sorry guys, 82.8. I don't know why it's doing that. 83.5. Okay. So in order to know my X and Y values, I make sure that I have the same number of X values as I do Y values. Okay? And then I'm going to go to stats. And instead of doing least squares, the line of its fit, first thing I'm going to do is do my scatter plot. So I'm going to go to stat plot, and I turn it on. I go to second, Y equals, and I press enter, and I highlight plot to put it on. And it automatically defaults to a scatter plot. And remember, this is the same menu where you do your box and whisker or your histograms as well. Okay? So I turn it on, and then I press my cute little graph button. Okay, you see how nothing came up here, right? So I'm going to press my zoom button, and I go all the way down to stat. Zoom stat, and I press enter, and there is my cute little scatter plot. And as you can see, there's a very strong linear positive relationship. It's probably one of the strongest linear relationships I've seen. Okay, and then I can go to calculate the line of best fit. So least squares regression lines, I'm going to do stat calc. And instead 4, go to LinReg number 8. It's not the end of the world if you do go to 4, but this is what the way we do it in statistics. Okay, so press enter. My x list is L1, my y list is L2, my frequency list, it doesn't matter. It says store regression equation. Now, if I want to see what the line of best fit looks like, I can do that, and I can press second vars, and go under y vars and press function, and that tells me to store it in y1, and that will enable me to graph it. It's not the end of the world if you can't do that, because you can just enter it in there. So here I've got my A, my B. Remember, A is your y-intercept, B is your slope, r squared is your correlation. You've got your r squared and you've got your correlation number right here. Okay, so one of the things that you guys need to do is be able to interpret the slope of the least square regression line into a sentence. So the slope is right here, it's 6.35, and what we're going to say, we put it in the context of the problem. So the x value is the age, and the y value is the height. So that tells us that for every 1 month in age, Paul's height in centimeters increases by 0.635 centimeters. And then your y-intercept is, and you don't have to do this, but it's not asking for it here, but I wanted to show you that at age 0 months, predicted height is 64.2928. Okay, that just tells you at the point where at 0, when x is equal to 0, that's what height is projected to be, the predicted height. Okay, and then we say, okay, let's take that one step further and say, let's predict the mean height of a child that's 42 months old and show your work. So you can plug this into 42 months old, and that's the number of months. So you plug that in for your x value, and you get 91.597 centimeters. I would say this is not you can't be very confident in this, because we've gone from the largest one we had was 29, and we went all the way to 42. Now, sometimes you're not going to be able to determine with great confidence whether or not it's extrapolation or not. Go ahead and plug it in, and if you plug it in, and if it doesn't seem like it makes a lot of sense, or if it seems like it's kind of out there, then I would say, yeah, that's when your extrapolation is happening. Okay? So if we predicted the mean height for a child that was 24 months old using our least squared regression line, we'd say it was 80.167. When we look at the actual data, it was 79.9. So what we did from here is we're going to calculate the residual, which is the actual minus the predicted, which is right here. So when the residual is negative, it's an overestimate. And when the residual is positive, it's an underestimate. And what I want you to do is think about it in the context of what is a residual. It's the actual minus the predicted. So when we predicted that this was too high, it was higher than what actually occurred, we have a negative residual. If it's lower than what actually occurred, we'd have a positive residual. Okay? Now, moving on, I'm going to try to go through this whole thing right here. Okay. How old is a child if they expect to be 100 centimeters long? So what I did is I set this equation equal to 100, and I solved for x, and I got 55.23. Now, ideally for good linear data, the sum of the residuals is going to be 0. So that's what we want to happen. Okay, that's when we have really nice residuals. So now to do a residual plot. Now again, you don't have to do this in the calculator, but I wanted to show you how we did that. Okay, so I'm going to go back to my stat and go under edit. So we have our months and our predicted value, our actual values, and now I'm going to do my predicted values here. So I can do actual minus predicted. So under L3, I can enter a formula. And that formula is my least regression line. Okay, so I'm going to use this formula right here. So I'm going to do 64.928, which is my y-intercept, plus 0.635, and that's times x. So what is x? X is these values right here in L1. So to do that, I press my second and 1, and that tells me to use the values from L1. Okay? And I press enter. And I get all these. These are the actual, these are the predicted. So now I have to calculate my residuals here, and I'm going to do actual minus predicted. So I go up here, and for L2, for L4, I'm going to do actual minus predicted, which is just going to be L2, which is second 2, minus L3, second 3. All right, then I enter. And these are my cute little residuals right here. Okay, so these are my residuals. Now I want to go back and I want to graph them. Okay, so I want to graph this. I don't want to graph what I used for L1 and L2. So I'm going to go back to my stat plot right here. I'm going to turn this guy off because this is using L1 and L2. I want to use L1 and L4. Okay, L1 is still the same x values, and L4 is my actual residual. So I go into here, and I'm going to turn it off. Okay, then I quit out, and then I'm going to go back. Then I'm going to put up that plot 2. Okay, I'm going to press enter and on. Okay, so my x is still L1. It's the number of months. But my y was, I'm going to change to L4 because those are my residual plots. So I'm going to do second 4, and then I'm going to graph it. And this is the least squares regression line. Actually, I'm going to go back and turn this off. I'm going to go to y equals and turn this off. Clear this one out. Okay, so then I graph it, and you can see I don't have anything in here. So I have to do a zoom fit again, or zoom stat, which is better. And there's my residual plot right there. So that is what I transferred to here. Now, remember, a negative residual, right, means that the actual was less than what was predicted. So these are all overestimates, okay? When you have the actuals much greater than the residual, these are your underestimates, okay? And right here is just about perfect, right? So, because there's no pattern, it's a scattered pattern, a linear model is appropriate for this. So, remember that the residual plot tells us whether or not a linear model is appropriate, and as long as it doesn't have like a curve pattern or anything like that, we're okay. All right. What can be made from the previous questions? Does the age of child cause the height of a child? Age of a child cause the height of the child? No. Why or why not? No. Association does not imply causation. There's a strong association between age and height, and the linear model does a good job of describing this relationship. So, but you cannot say that, oh, the older the kid, the taller they'll be. That's not necessarily true. Okay, so correlation does not equal causation. Now, I'm pretty sure I went on to 15 with you guys. So, but this is just taking these values and calculating the mean and standard deviation. And I hope they're helpful to you. Again, these formulas are going to be given to you. You just need to know what they mean. All right. This is your slope. This is the regression value or whatever. And that's the standard deviation y over standard deviation of x. This is the mean of the y values and the mean of the x values. Okay? So I just wanted to give you an idea where that is. I think that was the end of the first video. We went on later on to take a Minitab output and predict it, create create the least squares regression line. I'm going to quickly touch on that. So whenever you have a Minitab output, we're going to really just pay attention to this column and these things here for least squares regression. Okay? Your constant is your y-intercept, what we call b naught. Okay? Directly under that is going to be your slope. All right? Here's your standard deviation of your residuals, and here's your R squared. Okay? So I've created that. Now the value of the correlation coefficient, which is R, is the square root of R squared. Makes sense, right? R squared is equal to this. So the square root of R squared is equal to that, right? Correlation coefficient tells you what the strength and form of the relationship, as long as you can tell me it's linear. But it doesn't tell you if it's linear. Graph and the residual plot tells you if it's linear. Okay? So the slope in the context of the problem, again, you'll have to be able to do this. So for every additional minute a salesperson spends with a customer, the dollar amount of the sale goes up by 0.5679. All right? What does the coefficient of determination mean? It means that 78.96 of the change in money spent is explained by the change in minutes, or just say by the least squares regression line. Okay? Please, a couple more things I want you to do is always use y hat. Make sure you're talking about predicted values, not the actual values. Make sure that you're always emphasizing that. And so hopefully that's helpful. If there's anything else you want me to go over, I'll be happy to do it. The next video I'm going to make is going to be going over your review quiz. Okay? So I hope you guys, this is helpful to you. Please let me know if there's anything else I can do. And I really hope the sound turned out. Thanks, guys. Talk to you later.